Anyone? Okay. So let me just tell you. So composting is aerobic digestion, and biomethanation is anaerobic digestion. So basically, you need air for to produce compost, basically. So there is aerobic bacteria that uses the air and then it decomposes the organic matter. So there is a lot of CO2 formed, but that's okay because it's from organic matter. So that CO2 is kind of carbon neutral. So that's absolutely fine. And what remains is this inorganic compost, basically, and that can be used as fertilizer. It's rich in a lot of nutrients like nitrogen, phosphorus, potassium, and all that. And then anaerobic digestion, on the other hand, requires, I mean, in fact, there should be no penetration of air into that layer where anaerobic digestion is taking place. So that kind of leads to formation of methane. So the anaerobic bacteria digests this, decomposes this on organic matter and produces methane. Okay. So this kind of anaerobic digestion happens in one more place during in agriculture, that is during paddy cultivation, where we flood the fields, right? So the fields are like completely flooded. So on top, it's okay because it has a layer of air. But as you go down the layers, when I mean in the flooded layer, right, inside it creates an anaerobic condition. So that creates this anaerobic digestion of organic matter in the soil, and a lot of methane emission happens. So this is why when we talk about biomass, normally paddy biomass is looked at with kind of a suspicion because of this methane emission. Methane is like 25 times more potent than carbon dioxide in terms of greenhouse effect, basically. Okay. So more on that in a few days when we talk about all of these things. So let's move on to circular economy right now. Okay. So what is circular economy? As we were just discussing, the food waste and what we could do with it and all that. So there is so what we talked about composting and methanation of food waste, that is an end of pipeline solution. That is the utility of that food is over. That food can no longer be eaten. So what can we do with the food that is of use to us? So that is kind of an end of pipeline. So we have reached the end of its useful life. Now what do we do with it? So kind of in terms of materials, if we talk, it's kind of like recycling. Okay. But circular economy is much more than that. Okay. So basically it is concerned with the production, distribution, trade, and consumption of goods and services. Okay. And it can be on the level of individuals, businesses, or governments, organizations, all of these things. Okay. And uh, say the production of goods includes like from the raw materials and then the conversion into the final product, distribution and supply, and then finally after the use it reaches the it's I mean it has to be disposed or recycled or whatever. So this is the normal cycle that we follow. Okay. uh, in theory, all of the materials that we use, right, all the materials that we use, metals or plastic, oil, whatever it is, can be returned to the environment. That's how it should be. But then with the advent of the industrial revolution and everything, we have started following a more linear economy approach where we take these, like we discussed yesterday about the linear approach of the manufacturing cycle, where we take natural resources from the environment, we manufacture something, we use it, that leads to economic development and more jobs, and that leads to more demand for natural resources, and this cycle continues. So this kind of model is called the take, make, dispose model. So it's a linear approach. So we take raw materials, we convert it into products, we use the products, and then we dispose the products. Okay, so we are not doing anything else with that. So there is no cyclic flow that happens, which makes it highly unsustainable. And why is that so? Because we live in a planet with finite resources. So it's very important to understand that. So we are using resources, and especially corporations and even people, uh, especially people who are quite well off, right? So they are living as if this planet has unlimited resources, which is not the case, right? So we have finite resources. We have to make do with whatever resources we have. And as this sustainability, the definition of sustainability goes, we also have to think about the future generation. When we don't do that, then it's not sustainable, right? So, what is a broad definition of circular economy? So it's basically it has to we have to replace this end of life or end of pipeline concept, okay? And then so we could either delay the end of life or we could end it altogether. How do we do that? So we could reuse, recycle, recover materials in various stages of the value chain. So it could be during the extraction of raw materials, it could be during production, distribution, usage, and even at the end of its useful life, like in the example of the food, the waste food, right? The food cannot be eaten. So what do we do with that? So that is an end of pipeline solution. But even before that, so how do we minimize the wastage of food in this case? So let me ask you this. Yeah, can we can we have an answer? So we talked about end of pipeline solution for the food itself. When the food has become a waste, what do we do with it? Okay, we can compost it. We can, uh, you know, produce methane with it. But how do we ensure that this wastage itself does not happen?
Before the food goes bad,
Yeah,
if it's like a very large event happening and a lot of
yeah,
food is left out, we can donate that food to the orphanages or any uh, help home. What is that? Yeah, orphanages
perfect,
or something like that.
perfect. So that is one solution. Another solution is let's go even further back in time. So you're talking, okay, first we talked about, we're going in reverse right now. So we talked about when the food goes bad, what do we do with it? Now we talked about before the food gas goes bad, what do we do with it? Right? So
Hmm.
to prevent it
Yes.
from going bad, and when we know that there's a lot of excess food, okay, let's go further back and think one step back. Like,
Even before the food is prepared, we have
yeah,
to analyze how many people are going to come, and based on that, we have to prepare the food.
yes, absolutely. Okay. So that is the logical progression of how it happens, right? So first we plan, but then not everything might go to plan, right?
Yes.
So it may be that
Yes.
okay, there may be more people or less people or whatever it is for whatever reason. We know now that the food is going to go bad because there are not as many people as we would have liked. Okay. So the second solution is okay, let's give it to someone who actually needs this food. Okay.
Yes.
Or okay, when if we are not able to do that, what happens? The food goes bad. Okay, what do we do then? Then we go to the end of pipeline solution, and we know that okay, this food can no longer be eaten. There is one more solution here. So we can also store the food if possible. We can store it,
Oh,
have it for later, tomorrow, day after, whatever it is. Okay, that is also one solution. If that is not possible, then okay, you just instead of just throwing the food away, okay, you compost it, you produce methane, anaerobic digestion, or whatever. So in Bangalore, there is a rule. I don't know if it's the case in Bangalore and other cities as well. So if there are housing societies with more than I think 50 flats, they have to have an in-house composting this plant actually. Okay, organic waste composting. So they'll collect from all the houses and then they'll compost it right there, and the compost will be sent to wherever it is. I mean, to farms or whatever it is. So they're doing it in my society actually. Okay, if you have any
Mhm.
such experiences or in Mangalore, if you have seen it, you could just share. Anyone?
In Karkala, I have not seen any such thing yet, sir.
Okay, okay. Okay, that's fine. So normally, I mean, this is a very good policy that they have implemented, because a lot of these high-end societies are finally, stepping up the game and actually building these plants, and they're actually generating compost right here within the society. Okay. And it doesn't have to be just food that goes bad. It's also during the preparation, there will be a lot of organic waste that goes in here, right?
Yes,
So
yes,
that's what the circular economy does. It could be at any level. It could be at micro level, where I could talk about products, companies, or consumers. At meso level, like industrial parks, and at macro level, at city, region, nation, national level. So at the city level, this is what has happened so far. And with respect to dry waste, so far nothing has happened. Not much of substance has happened, at least in Bangalore. So we'll be talking about Indore in a while. So you'll see that how they have succeeded in doing this, right? Okay.
yes.
So the next one is how this circular economy evolved. So there are two cycles basically. So we talked about the food. So that comes under the biological cycle, where you have the plants, okay, and then from the plants you have you produce something. Let's say here in this case it's the food, okay. The production process is the cooking, and then the product is the food, and then you the use phase is where you eat the food, and then you have the waste, or either the waste food or the waste the peels and the organic matter basically. So those are returned to the environment through as biological nutrients through composting, or through biomethanation, or whatever it is. So that is the biological cycle. The technical cycle is very similar to biological cycle. So this is for wet waste. The other one is for for dry waste. So you have technical nutrients. So for example, the metals, okay, the aluminum, iron, copper, etc. Then you have the production of whatever technology or any vehicle. Let's say, okay, let's take the example of a vehicle. The product is a car, let's say, and so you use it for whatever 10 or 15 years. At the end of 15 years, it's normally scrapped. That's the useful life of this this vehicle basically, okay. And then once the useful life is done, then the car is scrapped, right? So if you want to reuse the parts, you need to dismantle the car. You need to separate the metal from the plastic parts and the semiconductor parts, and so on and so forth, and then you have to send them to different industries to try and salvage what can be used, and then what cannot be used has to be discarded, or uh, basically disposed. That's it. Okay. So, the what is the implication of circular economy? It is just to avoid the disposal of products. So basically, instead of saying, okay, there is a landfill there, I'll try to salvage what is there, and try to reuse it, so or recycle it. Instead of doing that, why not just prevent the materials reaching the landfill in the first place? Okay. So, so what is the depth of this idea? So it is not, like I said, it's not just about bringing the end of life back into the system. Like I said, don't go to the landfill and then try to create a product out of that. That can also be done, because the landfill has a lot of organic matter also, so that can be converted, let's say, into methane. Okay, but it is about sustaining that cycle in the long term. So it's about prolonging the useful life of a product, okay, in such a fashion that it takes a long time, if at all, to reach the landfill in the first place. Okay. So to achieve that, you have to reuse, recycle, or remanufacture. Okay. And so this approach will ultimately lead to sustainability because you're basically using the same materials again and again and again. Okay. So what are the approaches, the R's basically? So you have refuse. So if you don't need something, you just have to refuse it. So we use a lot of things that we don't need actually, right? So that has happened, especially that happens when we grow economically. And if you see all these um, Western economies, basically Western countries which are quite economically well ahead, right? So they are the ones who consume a lot of material, basically. So in fact, I read a report a few years ago saying that the US consumes like 25% of the world's resources. So that's how bad it is. It's one country consuming 25% of the resources, and they don't actually need it. It's just stuff that they don't need that they are buying and they're using it. Okay. Then rethink, reduce whatever you don't need. Reuse, we talked about this. Okay. So basically, instead of disposing it, you can reuse if it is possible to reuse. Are you able to see this actually? I mean, it's a little small actually, this one. Is it visible? Yeah.
No, sir, it's
Okay.
little
Yes, sir.
blurred.
It's blurred, right? One second, one second. Let me just
Zoom in.
I'll just increase the size of this thing. To see. Wait, one second. Yeah. Is it better now?
Yes, sir. Yes, sir.
Yeah. So before it goes into the disposal, you can try and reuse it. So
Yes.
you're using it, you're reusing it. So one example of reuse is like we all have would have done this when we were younger, right? So we would have had these books, right, for school and stuff, the textbooks and all that. We would have given it to someone, or we would have sold it for half rate to someone who's coming after us, right? A lot of us would have done this. So can you raise hands who have done this? Yeah, I would also raise my hand because yeah, even I've done this, right? So quite a lot of people have done this basically, right? So that's a very good example of reuse. So instead of that person buying a new book which directly leads to manufacture or rather production of this book, that will lead to production of more paper and cutting of more trees, right? Instead, if you just give your books to someone who needs it, okay, he can just reuse it, and then that person can in turn give it to someone else, and then someone else. So if we continue this cycle for at least let's say 4 or 5 times, so we are basically reducing the resources required by at least this 5 times. So instead of 5 people buying the same book, it's one person buying and then 5 people sharing it, right? So that's a very good example of this. And we'd have also done this with our old clothes, giving it to some orphanage and stuff, right? So that's another example of reusing old stuff and stuff that we would have discarded, but we're trying to find new use for it. Okay. So we can also try to remanufacture or refurbish. So if it is not completely destroyed, basically, you can try to replace some parts of it So that's what refurbishing is. And then remanufacturing, you try to repair the whole thing. Okay. Or if none of this is possible, you just have to recycle. You just have to dismantle everything, try to salvage all the parts, and then try to use these parts and let's say other products, right? So these are the R's basically. Okay, but the most important ones are these: reuse, remanufacture, refurbish, recycle. Okay, and repair is one very important R, because that is what basically prolongs the life of your product. Okay, so you can't just discard something that you use once, and if you feel that it's malfunctioning for the first time, then then you can't just discard it, right? So yeah. So for the circular economy approach, you need to you need to adopt a systems thinking approach. So I'll tell you what this is, but let me ask you this. If you want to measure, if you want to measure the uh, carbon emissions of your house, okay, how would you do that? So let's say you want to measure the carbon emissions. You want to calculate how much carbon my household is emitting. How do you do that? So that's the question.
So one thing is how
Mhm.
much energy we're consuming, electricity we're consuming,
Yeah,
because
perfect.
most of the
But
energy comes
my
from
question to you
food,
here
right?
is electricity. Yes, electricity is one very important factor here. But let me ask you this: electricity is not directly emitting any carbon dioxide at your home, at the premises of your house, unless you are using a diesel generator. Okay.
Yes,
So what do you do in that
exactly. So
case?
it is indirectly, right? Because the electricity produced is
Yeah,
always hydroelectric or solar, but
yeah,
from the power plants like Adani power plant in Mangalore.
perfect. So it's a thermal power plant, or it may be oil-based or coal-based
Yes,
power plant, from which or
yes,
you'd see the mix of power, like electricity mix basically. So what portion of your electricity is renewable, what portion is non-renewable? And right now in India, around I think when it comes to installed capacity, we have around 30% renewables. But then when it comes to electricity production, 80% is from thermal power, like coal, actually, right? Only the remaining 20% is from other clean sources, basically. Okay, so we'll come to this discussion later. So when people say that okay, electric vehicles are so sustainable, I just laugh at them, because I mean, come on, 80% of it is coming from coal, right? So
yes,
yeah, just because you can't see the pollution happening doesn't mean that it doesn't exist. And that exactly is what systems thinking approach is, or it can also be called life cycle approach, basically. So you have this system. So I just give you an example of this house, right? Your house, you are using electricity alone. You're not polluting directly in your house. You're not having a diesel generator. You're not polluting directly. But then the electricity that you're using has to come from somewhere, which uses thermal power plant, which in turn emits carbon dioxide. So it's an indirect emission. So you need to look at the system. You have to look at the subsystems within that system, or within the premises, basically. And you also have to look at the external systems and subsystems that affect the overall picture. So you need to look at the big picture, and that is basically systems thinking approach. Okay. So by doing this, what will happen is we can identify ways in which we are going wrong, basically. Okay, where we can improve, and then we can try to put our money where it is actually required. So instead of saying, let's say, um, okay, I'm not using any diesel generator, so I'm not polluting at all. Okay, So instead of saying that, let's say that okay, 80% of my electricity is coming from so from thermal. Okay, why don't and I have a roof. Okay, why don't I just install a solar power plant right on my roof, and then I can become a prosumer. That is, I can produce solar power. I can consume it as well, and I can also send some back to the grid when I don't need it. Right, and I can get compensated for it. So that's the way of thinking. This is called the systems thinking approach. Okay, so now we come to the case study, that is the Indore, the success of Indore. So during the Swachh Bharat mission, so Indore has been consistently at the top, and it's not due to any. It's not a coincidence actually. They have done quite a lot of work. So if you look at the composition of the municipal solid waste in Indore, so you have the compostables, that is around 40%. You have paper and plastics, and then you have ash. Okay, so ash and stones, they cannot be used; they have to be discarded. But they are not polluting as well; they are inerts basically. Okay, and they're producing about more than 1,000 tons per day. Okay, so what have they done? So basically, they have achieved waste segregation at source at 100% of the households and commercial establishments. So that is a very rare thing to do in India. And how have they done that? That is, they have, uh, carried out extensive awareness campaigns during religious and cultural festivals, like in Ganesh Pandals and all that. So they'll go there. These Indore Municipal Corporation employees will go there, and then they'll have all these programs that explains the benefits of segregation, waste segregation, and source. So, but it's not just the authorities that were involved in this. Even the people, they responded to it in a positive way, right? That is very important. Okay, so there was door-to-door collection for domestic other households, and then bulk collection for the commercial establishments. Okay, and they had a detailed route plan. In fact, there was an app there is in fact an app for the workers, for the collectors, garbage collectors, basically. Okay, and in that app there will be an optimized route that they have to take. So they have to go through that route only. If they deviate, then there'll be questions. So why did you deviate here? So they follow this route every day, and then at the exact same time they reach. I mean, they collect from all these houses. Okay, and then they have built all these garbage collection stations where secondary segregation happens. Okay, so secondary segregation, as in you have the dry waste, right? You have the wet waste separately, and you have the dry waste separately. So in the dry waste, you have to separate the paper, plastic, the semiconductors, the metals, and so on. Right? Right. 1 second. I think someone is not muted. Yeah. Okay. And yeah. So in these collection centers, they do a secondary segregation sort of, and they send the semiconductors to a particular industry where they are interested. One very interesting thing is here is that the plastic waste that they collect, right? What they do with that is the polythene waste, basically. Sorry. Yeah. So the polythene waste, they are cleaned, they are briquetted actually. So they're cleaned and then they're briquetted and they're sent to sold to pipe manufacturers. The PVC requires plastic, right? So these plastic briquettes are sent to pipe manufacturers. And some other waste plastic is also sent to road contractors, basically, because it can be mixed with tar, basically, and it can be laid on the road. So basically, what they do is they reduce the tar required by about 15% by doing this. Okay, and with the wet waste, what they do is they send it to for biogas generation. So we were just talking about biogas generation from organic waste, right? So there are so many biogas generation plants. They generate about 600 million tons. Sorry, 600 metric tons of biogas per day. Okay, and they have introduced these CBG buses that run on compressed biogas. And there is a plant situated very close to a market. So the waste, organic waste from this vegetable market also comes to the biogas plant, and they produce a lot of biogas. Okay. And then these garbage collection stations, right? Garbage transfer stations, they are self-sufficient in terms of energy because they use the wet waste generated. They produce biogas, and then you use this biogas to produce their own electricity. Where it's not sufficient, they use solar PV, rooftop solar PV. So it is complete self-reliance. Okay. And yeah, they are operating about 15 buses for to run more than 2000 kilometer per day using just biogas. So that's pretty impressive. So coming to the next case study, so this is a case study from 2010, but it's still relevant actually. So this is a biomass to bioethanol case study, and they've done a multi-stage optimization of a bioethanol supply chain. So what does a bioethanol supply chain entail basically? So you have the biomass, that is agro residues, right? You have agriculture, the waste of agriculture, like you have rice straw, wheat straw, and rice husk. And let's say there are millets. So you have stalks of this millets, maize cobs. All of these are waste which are not used. Could be burnt, or it could be they would feed it to the cattle. But after doing so, what would they do? They will just throw it in the garbage. Right? It's of no use to the farmers or the local community. So what can be done is these can be transported to the bioethanol plant, and it can be fermented into ethanol, basically. So this is called second generation ethanol. We'll be talking about ethanol in maybe in about 5 or 6 days. Okay. So this study optimized the cost of producing ethanol over the long term. Okay, and they have incorporated a lot of constraints. Okay, and why I have included this study is how this incorporates the circular economy concept. I just wanted to explain. So you have the agriculture, and you have the demand centers, which is the cities, right? The major demand centers. So you have food from agriculture that, or crops from agriculture that come to these cities. And the residues, they go into this biorefinery to produce ethanol, bioethanol, right? So bioethanol is basically, it could be used directly as a biofuel, or it could be blended with petrol. So as of now, we are having a program called ethanol blending program, which envisages a 20% blend of ethanol and petrol by the year 2025. That is next year. Okay. So as of now, we crossed about 10%, I think, 2 years back. So now we'll be about 12, 13 or something like that. But we are running into some problems because the ethanol blending program is using predominantly first generation ethanol, which is, converting these grains like maize and rice and sugarcane juice, etc., directly into ethanol. So what happens in that case is it's a conflict between food and fuel. And this same conflict arose about 20, 30 years ago in Brazil and in the United States. Right now, we are also facing this. So because of this, we don't have enough sugar cane for sugar to produce sugar, and the sugar prices have gone up. So just last year, the government said, okay, let's put this on hold for now. We'll focus on sugar, and then once the production is up to the mark, we'll come back to ethanol. So it's like a monkey balancing that's happening here. And that is where this kind of second generation ethanol comes into play, where we are using the waste residues instead of using the crop itself, instead of using the grain itself, we're using the waste residues. Of course, the efficiency is not as great as the first generation. Why? Because, okay, can someone tell me why? So you have these grains, okay? It could be sugarcane, maize, or rice, or whatever grain it is. Converting that into ethanol or fermenting that into ethanol uh, is quite an easy task. But then you have these residues like the straws, cobs, and so on. Converting that into ethanol is a very tedious task. It kind of requires a lot of technologies, or two or three stages, in fact. And then it also require. I mean, it's quite expensive as well. Can someone explain why this is so? In a fundamental way, it is. It's a very fundamental thing.
So the grains and all are the concentrated products, whereas the stock and all are just the byproducts, like
Yeah,
not the main
but
product. That's true.
why is it that the grains converting the grain into ethanol is easier compared to the residues? I mean, let's take even if you take it evenly, let's say 1 kg of grain and 1 kg of rice straw, let's say, you would produce much more ethanol from the rice grain, 1 kg of rice grain compared to the rice straw. So why is that so? Anyone?
Like the rice grains and all are just the ready to use, right? Whereas the
Uh,
straw has to undergo many processes to be ready to give out the
Yeah,
ethanol.
you're right there, but then there's one thing that you're missing there, just one step. So what is that? What does that mean, ready to use? So
Hmm.
okay, what is required for fermentation? What gets fermented actually? So that is the basic question here.
Sugar.
The sugar and
Exactly, exactly. So the grains, they have a lot of sugar, right? They are basically like rice, maize, and all. It has carbohydrates, monosaccharides, all of these things, which can be readily fermented. Okay. In case of residues, it is made of cellulose and hemicellulose and lignin. Okay. So that is why we call it lignocellulosic biomass. So lignin is like a protective cover. So if the lignin is quite strong, like in case of wood, so wood is also biomass, rice straw is also biomass. So you cannot just wood is not flexible. You cannot just bend it. But rice straw you can just bend it. How? Why? Because wood has a lot of lignin compared to the rice straw, and which is why it is very strong. Wood is quite strong. So lignin gives strength to the stem or the biomass basically. Okay. So rice straw has less lignin, right? Rice straw and all of these other biomass, they have very less lignin. But the cellulose and hemicellulose are not easily fermentable. So you need to do some pre-treatment, like it could be physical, chemical, or biological pre-treatment as well. So you need to do this pre-treatment to release the sugars, the C5 and C6 monomers that can be finally fermented. So you have like these three steps. The first step is to break the lignin. Okay. So you need to use only the biomass that have less lignin content. So it is easier. So break the lignin, break the structure of the biomass basically, and then you get lignin as a byproduct. And then the cellulose and hemicellulose has to be pre-treated to release the monomers, the C5 and C6 sugars basically. And then the final step is the fermentation. So it is quite a tedious process, and which is why it is very expensive also. In fact, it is 10 times more expensive than first generation ethanol. So in 2018, what happened is the national policy on biofuels came out where they were planning to build about 12 biorefineries of 2G ethanol. So far, only one has been built. This was supposed to happen by 2022, but in 2022, only one opened, that is in Panipat in Haryana. From the others, I think one more is being built. They had allocated money for 12, but no one wants to invest in 2G ethanol because of the cost constraints. Okay. So yeah, the biofuel is produced using the crop residues, and then the fuel can be used again in agriculture, for tractors and the other machinery, everything. And the fuel also goes to the blended fuel also goes to the demand centers, that is the cities. Now, from the cities, you also have municipal solid waste, which can again be used for either fermentation or producing biogas, which can again be used as a fuel. So this loop is completed. So this is a perfect example of a circular economy concept, right? So we are at the end of today's lecture. So in case anyone has any questions, you can ask, and then we'll go into the Q&A.
So, like you said about
Hmm.
the composting, which is done in your community in Bangalore.
Right.
So, such things are implemented in the municipal level, right? Like
Yeah.
the initiatives have to be
Hmm.
given by the have to be taken by the municipality of our locality, right?
Uh, the compost, I think, is taken off by the municipality. Okay, but this
Hmm.
the plant itself is our own investment. I mean, the builder has to do it. So when he's building the constructing the house, right, constructing the buildings, he has to construct this plant as well. So this is
Okay.
totally our own. But how do we dispose of the compost? So that is taken care of by the municipality.
Okay.
Okay. We could also dispose it if we know that, okay, someone needs it or something, we can take it. That is left to us. But mostly at such large levels, right? It's the municipality that does that. Was that your question, or I mean,
Yes, sir. Yes, sir. That's it.
yeah.
In our area, in Karpara,
Mhm.
actually, there is a person who actually collects all the wet waste
Okay.
in order to take it to his farm or something.
Yeah. So even he would do some composting before he would use it on his farm.
Yes.
So he cannot just use wet waste just like that. Okay.
Hmm.
So let's say the vegetable peels or some organic waste from your kitchen and stuff like that, right? So you cannot just
Yes.
use it directly because that will start rotting,
Yeah. It will be
okay,
harmful
in
for
the
the.
open. So that will kind of be counterproductive because that will inhibit the growth of the plant. So he has to convert it into compost using the right bacteria and everything. Okay.
Yes. Yes.
So yeah, and it has to be maintained at the right temperature also. So I think it cannot be more than 40 degrees. It has to be between 25 and 35, something like that. And the
Hmm.
right amount of oxygen has to be given. Although, I mean, this composting plant that is there, that is operated through electricity. So we have all these blowers and everything that give the right amount of air to this to the plant and all that. That cannot be done probably by a farmer or something, but it's okay. It still works, right, as a composting plant.
Yes, sir.
Yeah. Anything else?
No, sir. That's it.
Okay. Okay, if there are no more questions, we'll go on to the Q&A. So, why is circular economy more sustainable than a linear economy?
All of the above,
Yeah. Why is it?
because all of them actually
Yeah, I mean, you
there.
explain point by point. Yeah.
Okay, sir. So circular economy ensures efficient resource usage by avoiding
Mm.
extraction of new materials. So if we have any material like a dead phone, we can
Mm.
recycle it and extract all the minerals so that it can be reused in some other in the production of mobiles or any such devices again.
Right. Right.
And then in reuse and repair of equipment reduces the new need for new manufacturing, thereby saving on costs.
Mm.
So if we have a device which we don't use but is actually working, so we
Mm.
can either donate it or sell it as a second-hand device which other people can use. And
Yeah.
Circular economy principles lead to better health and sanitation due to lesser amount of waste reaching landfill. Yeah,
Hmm.
when we do the needed, like before the waste reach the before it is converted into waste, we
Mhm.
can stop it from reaching to the landfills.
Right. So
Yes,
there is one, yeah, you're absolutely right. So it is all of the above, but there is one thing I just want to tell you about landfill. So have you visited any landfill or have you just been through it?
yes, sir.
So
In
yeah, so
Udupi, there is a place called Jodangudde. It used to
mm,
be a landfill, and this
right,
place used to stink a lot. But now they have
yeah. So
converted it to
why
a
is
ground.
that so? Do you know? Because it's because of the mixing of all the waste.
Yes, sir. Both
So you have
wet
the
and dry
organic waste
waste.
from which you get the stink, but then you are mixing it with all the inerts from, I mean, the paper, the plastic, everything, right? And that's where the
Yes,
problem
yes,
arises, right? So
yes,
if you can achieve door-to-door segregation, that's the best thing you can do, right?
yes, sir.
And then
Yes,
even if you are, discarding the rest of the materials, the dry waste and everything, that's not going to exactly harm us, except for if it is like, let's say, e-waste or something, which can
mm,
emit toxic gases or something. But other than that, it's not exactly going to harm us in any way. Okay, it will only lead to
yes,
depletion of resources. So it will be better if we, remanufacture or recycle all these materials. But then, yeah, we need to avoid mixing of waste definitely because um, yeah, so that's generally good for the environment and for the planet. In fact, one of the teams in our center, CST, is working on this. They recently had a demonstration on segregation of waste and everything, you know. So, yeah.
okay.
So, identify the cycle for the following circular economy measures. So, first is anaerobic digestion of garden waste, then remanufacturing of internal combustion engines, then repairing a broken mixer to prolong its life, and extracting and melting scrap metal from components.
D,
Yeah, why is it D?
because the first one you're doing a biocomposting thing,
Right.
because it's anaerobic, and then for the manufacture of engines, it's like you use the metal part, which is like reused,
Hmm.
and then the repairing a broken mixer, you're like reusing. No, I mean what is that word?
And just prolonging its life.
The
Yeah.
yeah,
To
and then
ensure that it doesn't reach the landfill earlier. Right. That's
yeah,
the
yeah.
that's what you're doing. Yeah.
Yeah, and extracting metal scrap is yeah, that's basically like recycling,
Yeah.
using the components.
Perfect. So it is D. The first is biological, the other three are technical cycles. So what is the systems thinking perspective? Anyone?
C is the answer.
Are you sure?
Mm, no, sir. But yeah, I choose C.
Was it C? Can you justify it?
Like we talked about electricity, right? So
Yeah.
even if we are using electricity and not running it on diesel generator,
Hmm.
we are actually taking part in the carbon emissions as
Right.
we are using the electricity generated by a thermal power plant.
Yeah, but you can look at the option again. It says the system under scrutiny. So system is your house,
Okay.
right? So
Yes.
you'll
Yes, sir.
you'll do an assessment of your house and you say, oh, I'm not polluting, I'm not generating anything.
Mm-hmm.
So that's like I said, that's basically the argument of the EV purists, should I say, or So people who talk very highly of EVs talk saying that, oh, it's non-polluting, and so there are these new buses in Bangalore, the BMTC buses, that has a tagline. Literally, the tagline is on the bus that says "Let the city breathe." So
Okay.
yeah, the city will breathe, definitely. There's no question about it. So there are no emissions coming from the tailpipe of the bus. But what about, some in some remote location where waste
The
plants are
power
running?
plant has been set up.
Yeah.
Yes.
So what's the answer to this?
It cannot be all of these, and it cannot be B. So I think it's A if it's not
Yeah.
C.
Why is it A?
Yeah, because just like we talked about, like not just a house, we have to see about the extended systems also. Like um,
Hmm.
the house gets current from some other system.
Yeah. Perfect.
Yes,
That's
so
the answer. Because yeah, you have to look at your system as well as the systems that are connected, the interconnected systems.
interconnected.
Okay.
Yes, sir.
So your upstream and downstream, we talked about the scope of emissions yesterday. So that's
Yeah,
exactly what this is. Okay. So you're using electricity from somewhere. You're doing something that, let's say you're producing something in your industry, you're using electricity from somewhere, you're sending your product somewhere else where it is being used and disposed. So all of this should become your system, basically. Okay. You're
Mhm.
just expanding the boundaries of your system to include everything instead of just what you are focusing on, which is your premises or your project or whatever it is. Okay.
Yes,
Yeah. So while linear economy follows an end of pipeline approach, circular economy works to minimize waste over the entire lifetime of a product. So basically, instead of just doing an end of life pipeline approach, we are trying to prolong the life of a product, of a technical, of a technology, or of a product, or let's say even a biological product. Okay, so that is what this circular economy is about. But there are some end of pipeline solutions to circular economy also. What are these? I mean, which among these are like end of pipeline?
recycle,
Yeah, why is it
recycling, sir.
so? Why is it so?
Because a repair is actually giving second life to it. Like it has not reached its end of life, and
Right.
reusing is basically it's still working. We can use it. And
Yeah.
reducing is we are not buying what we want, what we don't need. So
Hmm.
basically,
Hmm.
we are not starting its life. And
Right.
recycle is only when it is not working anymore, and we just want to use use the parts, use the parts for other
Yeah.
purpose, or extract uh, elements from it.
Perfect. So it
Once
has
it's
reached
completely,
its economic life, or its useful life, basically. So we spoke
yeah,
about the car, right? At the end of 15 years, what do we do? It may be working, but then, yeah. So we say, for all intents and purposes, okay, it's at the end of its useful life. So remove it, dismantle it. You use the metal parts, use the semiconductors. You use the try and use the plastic if you can. Uh, yeah, so that's exactly what recycle is. It's an end of pipeline solution. So instead of
yes,
it going into the landfill, instead of disposing it, you're just trying to reuse all the
bring it back
materials,
into the system.
bring it back into, yeah, yeah,
The
bring
cycle.
it back into circulation, basically,
Yes.
right? So which among the following measures indicates a circular economy approach?
D.
Yeah, can you justify it?
Yeah, because in the first one, you're using all the waste to make biogas from it. So that's
Yeah.
like, yeah. And then the second one, you're basically you reusing it because
Hmm.
you're giving it to like someone else to use it. And then the polythene, uh, yeah, you're basically like reusing it again. So,
Yeah. So the polythene buckets is, I think, recycle. It would come under recycling. Okay. So the first one would be again it's recycling. The second one will be reuse. Third one is recycling again. So all of these are circular economy approach. In fact, all of these measures have been taken by the Indore Municipal Corporation. So I told you about the first and third, but the second one, they have created something called a Bartan Bank, where for these functions like weddings and all, the people can go there and they can actually rent out these utensils, steel utensils, instead of using paper cups or plastic cups, right? The paper plates, plastic plates, and all that. So like in these big functions like weddings and all, how much paper and plastic wastes are generated. So instead of that, use stainless steel on rent. So how much of waste that will save, right?
Yes.
So yeah, so this is also something they are doing. So that's pretty commendable, I should say, actually. Okay. So how could
Yes.
the solar PV industry follow a truly circular approach in the future? So this is a discussion point. You can just put forward your points, your thoughts on this. So why have I asked this question in the first place? Can someone explain? I mean, you would think that renewable energy has to follow like circular economy principles by default, right? But that's actually not the case. So, do you know why?
Because whatever solar farms we have at the
Hmm.
moment,
Yeah.
they require a lot of maintenance, and
No, maintenance
the
is,
food,
I mean, the
yeah,
major
maintenance is must.
maintenance,
Yeah,
required is just cleaning of the panels. That's it.
panels. Yes, sir.
Yeah. Nothing more than that. There may be one or two that may have to be replaced over time. That's just general wear and tear.
Huh, okay.
I think end of life.
Like once the panels reach the end of life, what are they going to do about it? Like at
Yeah.
present, there is no such measures taken. Like
Mm,
after the government, I'm not sure, but please correct me.
yeah.
But whatever this solar panel mission was started,
Mm,
it is not that efficient because production of solar panels is much
mhm.
costlier, and it is
No,
not economically viable at the moment.
not really, not really. Let me tell you this story of how the solar mission started. Right, in 2010 it started. 2011 is when the first plants were installed under the solar mission. Right. So back then, the uh, cost of solar electricity was 17 rupees per unit. Okay,
Mhm.
in 2011. So over the years, what happens the first 4 5 years, it was like around that range. It dropped to maybe 13 rupees per unit or something. But then after that, we had all these panels. I think we spoke about this yesterday, but I'll just tell you. So we have all these panels coming in from China and Vietnam. And in general, the manufacturing of solar panels, the cost has gone down drastically. Okay.
Mhm.
So like for example, right now, 1 megawatt solar plant, if you want to install it, costs like about 4 crores. Okay.
Mhm.
In fact, coal power plant will cost even more. A diesel generator will cost more. In fact, diesel generator costs I think 7 to 8 crores for 1 megawatt. Okay, compared to solar. So if you want to install a solar power plant, it costs 4 crores for 1 megawatt. Okay, so and the electricity has gone down to 3 rupees right now. Okay, so
Mhm.
manufacturing or all of these, I mean, the cost is not an issue at all with solar. Cost is not an issue at all. You have to think in terms of okay, think in terms of circular economy. Let me tell you, end of pipeline solution. Okay, so that's the hint.
Uh, so can you hear me?
When
Yeah, I can.
Uh, Sir, then if that is the thought that it is cost efficient, then
Mhm.
can we build a large amount of solar panels which provide like lots of energy in Sahara deserts or in Rajasthan where we have? So because India has the world's
Mhm.
largest solar park, that is Badla Solar Park something. So,
Yeah.
sir, it will provide like 2000, like 200 megawatt, like watts of power. So that is
So
a
we
housing
have
of like,
in Karnataka and Pavagada, there's a 2000 megawatt plant. So all of these things are being done already. So that's why I'm saying don't think about the during its life. Let's come to the end of life. Okay, the useful life of solar PV module is like 25 years. Okay, now let's assume
okay,
that the 25 years are over. Now
okay.
we have come to the end. What do we do then?
So we'll
So
recycle.
Yeah. So how do we do that? Any idea? Yeah.
we could like use the semiconductors that are there inside, or the like the metal parts and stuff.
Yes. Yes, absolutely. So we can reuse the semiconductors if they are usable. Okay. And the the frames of this solar panel, they are made of aluminum, which can be reused, of course. Okay. And then the glass, if it can be retrieved and then recycled and reused. So you need to dismantle the entire panel and you have to reuse it. And in fact, a solar plant has a much more than just all of these. So you also have inverters, you have transformers, all of these things. Even those have to be dismantled and recycled, basically, right? So that's what I have here. So the semiconductor, we spoke about the semiconductor and aluminum parts. Okay. And according to a new research at our CST, Center for Sustainable Technologies, there's a group that works on end of life PV solutions. So they have found that these end of life PV, just as it is, can be used as facades or in place of walls in buildings, basically. Okay. So that's pretty cool. It's like, instead of recycling, you're reusing these panels for some other purpose, basically, right? So these are some of the ways. But as of now, there is no policy. So the first plants started in 2011. So plus 25 is what, 2036, right? So by within another 12 years, we'll have all these, the first generation of solar panels that get decommissioned. So what do we do with those? So there are some companies thinking along those directions, and they want to be ahead of the curve. So they're already having plans to, procure these modules and then do some kind of recycling or whatever it is. Okay, so that's a good thing. But I think when we reach that deadline of 2036, I think there will be some policies on what to do with these panels and the other equipment, right? But I hope we come up with some robust policies, because we don't want to end up with more e-waste, right? So we set out to solve one problem, that is global warming, by using solar power, and then we are creating another problem, that is e-waste, right? So, so which of the following players help make circular economy a reality?
See,
Why is it so?
because cement and steel manufacturing,
Mhm.
they might recycle it,
Mhm.
recycle the old ones, but they are
Mhm.
manufacturing new things. And
Yeah,
hedge fund managers are basically something related to money,
yeah,
is it? And yeah, cobblers are the ones who actually help us reuse and reduce.
yeah. How? I mean,
Like
how do they?
if we have a chappal or a shoes which has a torn, we can just take it to the cobbler and he'll repair it for us, and we can use it
Right.
for a much longer time instead of buying new ones immediately.
So let me ask you all this. When is the last time you visited a cobbler?
Mm,
Anyone? I mean, it is open to everyone, right? I just want to know, like, when is the last time any of us visited a cobbler? I can tell you, I visited about 6 months back, because I had these shoes that were, tearing at the bottom, and I didn't want to buy new shoes actually. And I said, no. I mean, people were saying, okay, why don't you buy something new? You've had this for like 4 or 5 years. I said, no, these are perfectly good. I just have to get it stitched or something, and then I can use it for another 2, 3 years. Right.
Yes.
So the issue is that when once we start, uh, I mean, getting economically, we grow economically, right? We start forgetting all the things that made us, uh, you know, so yeah, so made us what we are today, basically. Okay. So I remember a few years back when I was a kid, right? So you have all these milk packets, right? So my mother used to, keep all these milk packets, dry them, and then she used to sell it off to the Raddiwala and stuff. The same thing with the newspapers and all that. So how many of us do that? So me, I definitely don't do that because I'll just throw it away. I'll throw the milk packets away, right? So newspapers, sure, I'll just give it off to some NGO who can sell it off. So that's something different. But yeah, I mean, we were more sustainable when we had less money. So that's something that's ironical.
Yeah.
So we're
When
growing
we get
economically, but in terms of environment, where are we in terms of environmental growth? We are not there, right?
yes,
So yeah,
that is one thing we have to get educated about. Like
yeah. It's not about education. It's more like people start looking at status
realize it.
once. Yeah, so it's about about status than education. So we are all educated. Okay, and we all know that okay,
Yes.
doing this is more sustainable. It's better, than say something else. So like I told you about the shoes example, right? But
Yeah.
a lot of people they would like to show off their new shoes than go get it repaired or something. So that's something
Yes.
that I mean we need to grow out of this mindset. This is exactly the mindset that led to USA using up 25% of the world's resources.
Hmm.
So it's not they can emulate USA for a lot of things, but we chose the one thing we should not emulate. You know, so so that's something that we need to think about, right?
Yes, sir.
So the next question is let's discuss some examples of circular economy. So one example is handing over new clothes, or we spoke about the old books, right? Old clothes, sorry, old clothes and old books to others, right? Can you give me some other examples, just right from our own, day-to-day lives, or
One such example is if we don't use a device such as a mixie or
Mhm.
a laptop or anything, we can just
Hmm.
donate it or
Yes.
sell it second hand.
Yeah, we could do that.
Yes.
That can be done. Any
Or
other
like
example?
if
Yeah.
there is a waste which you can't like deal with it at all, you can just use it as a piece of decor or something like glass. Like I used to have these CDs which are just like
Uh,
stuck on the wall as decors, so I didn't really know what to do with it. So
that's a good example, but then a lot of people might not know what to do with it, or might not know how to turn it into a decor. So it's not a very common example, like you know. So if I had a CD or something, I would probably just throw it away because I'm not the creative type. That's
yeah,
that's funny. Yeah.
yeah.
So think books itself. There's one very beautiful example of circular economy with respect to books. What is it? So we spoke about handing it over to the next generation, or I mean, the one.
Recycling the pages. Like you can make
That is
new
end of
paper
end of
clips.
life. I'm talking about prolonging its life itself.
Sir,
Yes,
recycle
sir.
of
For
plastics, sir.
A recycle of
Plastics.
plastics from which one? Like from what?
Like we use in daily life. That plastics can recycle and we can use many times.
Sure, that can be used, but then right now it's not being done in many cities. It's being done in Indore, like we saw, for example. But again, that's an example of the end of life solution. So I'm talking about, I give you the hint of books, right? Books, prolonging the life of books. So can anyone come up with an example?
Okay, sir.
Yes, sir. So all the books which I used actually were from a cousin, and
Okay.
it was like I was like the third generation or the fourth generation using the
Yeah,
books
that
actually.
that example we already spoke about, right? I'm talking about another example.
If the like pages are
Okay.
torn or something, you can just like spiral bind it or something. Just like prolong its life.
Sure, okay, that can be done. Yeah, but then one very important example of how uh, the life of these books can be. So we all would have gone to this place.
Library.
Exactly,
Library.
exactly. Yeah, libraries. I mean, they have like thousands of books, and then they're basically promoting circular economy, right?
Yes.
So everyone goes, borrows, reads, and then returns to the library. So how many people have used these books, right? So instead of one person or two people. So the example that I gave you of, passing it on, maybe four or five people might use it and then it may get discarded, it may get torn, it may get, disposed of. But then libraries, it will stay there for, maybe 10, 15, 20 years at a stretch until it's no longer
Yes.
readable. Uh, any more examples?
Like related to books or anything else, sir?
Anything related to anything.
Mhm.
Just think in terms of the city itself. There's one more example in the city that,
Okay. So the vehicles, sir, like
yeah,
reusing those vehicles. Like there is a bunch of vehicle which we can rent and then give it back. So
yeah. So
it is
like
kind of
renting,
economic also, and it is helpful to the nature also. We're not buying new things.
yeah, perfect. So yeah, renting vehicles. So you have your Zoom car and stuff, right? So that is one
Yes,
example.
yes.
There's one more example with respect to vehicles itself. What is it?
Taxis.
Taxis, yes, very important. Yeah, taxis. But in addition to that, there's one more thing that you can
Public
use,
transport, public transport.
exactly,
Instead of
exactly.
many
Yeah,
vehicles coming onto the road, using
yeah,
one public transport can reduce a lot of
yeah,
vehicles.
yeah. So in fact, it will reduce the manufacture of the vehicle itself if everyone starts using public transport. But then the issue with public transport in our country is that it's not very
It's
reliable.
not,
That's the issue.
yes, yes, sir, yes, sir.
You know, that's the so I have all these examples here. So yeah, the first one is very interesting because in the earlier days you had all these agricultural residues as animal feed, right? You had rice straw and wheat straw which you used to feed to animals, and their uh, droppings, like their cow dung or something that you use as manure for the fields itself. So that's a perfect loop right there, and
Yes,
I
yes.
spoke about the old milk packets. So everything is here, but it's okay. Soaking excess cooked rice overnight. Yeah, another thing we used to do is, this, soaking this rice overnight, and then we used to have it with curd in the morning. Okay,
Mhm.
so that's also very good for the health because it gets fermented a little bit, right? So it's good for the gut
Yeah,
health, and also it also prevents the food from going bad. So we spoke about end of life solution for the food, or prolonging the life of the food, right? So
yes.
this is one way we can do this. Okay. And fourth example, we already spoke about utilizing secondhand books from siblings or cousins instead of purchasing new books. Then libraries. renting furniture. So there are companies like Furlenco or something. I think they rent out furniture. Like you can rent it out for like I mean rent it for like 6 months at a stretch or something like that. Okay. And in
Yes.
situ composting, which we again spoke about. Yeah, another very important example is printing on both sides of the paper. You know, so that's basically saving
Yes.
on paper. You know, that's preventing the manufacture of new papers, right? Instead of printing on a single page, use it print on both sides. Or sometimes what I do is even if I have to print only on one side, I use the second side as some rough for some rough work or something like that. So even that is a good example. And then of course, you know,
She was
repairing.
like, she'll call, like she would call them and tell us by Monday.
So can you just mute yourself? Okay. So yeah, then getting torn shoes and appliances repaired and efficient public transportation. Yeah, this also includes cabs. Like someone talked about taxis, right? So that's very important because we think that it's not very sustainable, but actually, yeah, it is because in a single day they may have like maybe 6 or 7 people traveling in the same taxi, right? So imagine the kind of utility that particular vehicle has, right? So these are some examples. So there are, of course, many more examples of circular economy, right? So we are at the end of today's lecture. So in case you have any questions or doubts, you may ask me.